Hello, everyone. Let's see if I can put that there. So I think I'm gonna just build on what's been talked about in the last panel. And I know this theme is around kind of security resilience, but I think my main argument here is that if you're in manufacturing, everything is security and resilience. Sustainability is security and resilience. Decentralization, or what's this? Microphone down. Ah, there we go. So everything to do with manufacturing is everything to do with cost, efficiency, which is and stability and adaptability, which is all to do with how resilient the operations go. With us as a company, and where we started Synbiosys, we actually started as a materials company. We came up with a hypothesis that we could use a new form of physics to develop a new family of armor materials. So we started at TRL 0. Literally, I think we can use this new form of physics. How many of you have tried to develop new materials? A few. How much time and money did that cost? A lot. And I think and then once you've developed it slightly, how much time and money did it take to get a customer to use it in their product? Decades, maybe, right? Tens of millions. And this is really the fundamental problem that we had to try to solve for ourselves. We knew straight away that, especially with something as niche as armor, we were not going to get VC funding because their timelines. I mean, if you want to get your armor onto a tank, that tank is the next generation tank has already been decided for 30 years' time. So we're talking about a 40-year procurement year cycle. So that's not going to happen. So we had to get a bit of government grant funding, but also try to develop this material in a new way. And we came up with all the typical problems that you experience when you develop and try to understand a new material. I don't know what I don't know. I can't model this using the traditional methods. Shooting stuff is really expensive. I do not want to do that very often. So how can I maximize the amount of information out of every experiment? The variability of the feedstock is enormous and is wildly impacting the performance of my material, right? Off-the-shelf materials, 1 micron difference in the thickness, 60% difference in the amount of energy that material absorbed, right? Huge. That's even before we get to the point of how do I get somebody else to trust this? How do I get somebody else to put it into their manufacturing process and onto their platform, right? And that's a typical valley of death for materials. And so if we want to look at making sustainable, recyclable coffee cups, if we want to make the next generation armor for tanks, if we want to replace metals with fiber composites for civilian aircraft, that's a huge undertaking. And with us, it all came down to basically the same fundamental problem, which is that of to validate and to, as Andy mentioned, to qualify materials, basically to trust something and to get somebody else to trust that thing takes far too much time, far too much money, and it's really complicated. Long story short, with us, we created a new methodology and framework to speed up this process. And we managed to get to TRL 4 in 80 tests and a couple of £100,000, close to dollars, which is a few orders of magnitude faster than in the armor world. They call it the Slapperton C method. When you develop a material, you make 10,000 samples, slap them, and then you map out the parameter space and off you go. And that's when we realized what we had of value wasn't the material, but the methodology and the mindset of like what paradigm are we trying to shift when we are developing and trusting a new material and manufacturing process. And use material and manufacturing processes interchangeable because they are ultimately one and the same thing when you start to deploy them into industry. And so I'm going to give you a few case studies from customers that all superficially seem quite different. So I have a production line. I want to automate it. I have similar production lines. How can I very quickly scale the automation of one production line to another one, which is 90% similar, without throwing consultants and engineers at the problem and millions of dollars, which is the same if it's a recycled coffee cup or whether it's an armor material. I have variable inputs. I have my production line. A perturbation happened in the supply chain, right? My supplier went down. I need to move to a new supplier. The material is the same, but it's not. right? It's slightly different. How do I recalibrate my production line in a way that I can do it in real time? So maybe I can, coming back to the resilience piece, if I can move from having one supplier to 10 suppliers, they're all slightly variable, how can I in real time change the production line parameters to maintain consistency of the product at the end? How can I reduce the time and cost to evaluate new materials into my product, whether that's a new metal into a 3D printer or a new sustainable feedstock or this coffee cup? And this can be a traditional, with supply chains went down with COVID, or if you're at the front line, right? And you are, what was the term that Andy used? I know the phrase modern battlefield foraging, which is like you're in some other place and you've got this bit of metal, you don't know what it is, and hey, I'm just going to weld it to my truck and I'm going to hope for the best. How can I trust this thing in a reasonable amount of time? How can I, as an OEM, leverage the millions of data points that I have on a wide variety of materials, a lot of them which are stuck in my engineers' heads, maybe use large language models to then extract understanding of the data set to then speed up the evaluation of this new material or to speed up the design process of a product that's using a new material. Let's say I have 15 3D printers in my production facility. It takes me a lot of time, a lot of money to qualify each material on each printer and each part's made on that. If I change the part, change the printer, move the printer, whoop, you start all over again. But I have these 15 qualified machines. I've just bought the 16th one. Why is it taking me the same amount of time to qualify this 16th one, given I have all of this knowledge captured within the models that I've developed for these 15 3D printers and the tacit knowledge within my workers? And then if we take it to the extreme, I've got this printer, I've moved it over there. Let's say if you're at the front line, how can I quickly get that printer up to trust as quickly as possible without going through the typical qualification process, right? They all seem quite difficult, like different problems, right? And ultimately it comes down to how do I tie together, contextualize, and validate or qualify the evidence that encapsulates the understanding of whatever you're trying to trust. And evidence is a mixture of data, it's a mixture of models, and it's a mixture of know-how. And trust really lies in the burden of curating this, reconciling this, and leveraging it to come up with a decision with a certain level of confidence. So this is a lot of information, I know. The way that we establish this trust, the way that we reconcile all these different bits of information is incredibly manual. I have my subject matter expert in the material. I've got my subject matter expert in the 3D printer. I've got my design engineer. I've got my factory floor operator. They all speak different languages. They all store data in different ways. They all model things in different ways. And generally, when you qualify something, you will build a model and then you validate that model based on experimentation, right? And you tie it together and then that person then hands that over to that person. This is the process that takes literal decades in order for so everyone needs to establish trust in their own little thing, and then they need to hand over that information to someone else who speaks a different language, and they need to trust that process as well. All very manual. And I think this is the paradigm kind of shift that we need to have is in how do we transfer trust from what's in your head and from your data set into someone that knows nothing about what you do. And that's ultimately what we as Synbiosys are trying to do, which is to lay the foundation, the ability to pull together many disparate and different models and many disparate and different data sets and have them acting in congruency in an automated fashion. So that, as an example, we are working with a steel factory. They wanted to automate a production line. This could be for a defense product or not for a defense product. They wanted to automate this production line. They already knew that they had huge inefficiencies in their system. They didn't know they had no employees that knew anything about digitization, but they did have Fred with 30 years of knowledge on how to drive the system. So they went, Synbiosys, can you put AI on this machine and get it automated? And we went, sure. Where's the data? It's in the operator's booth. It's on a Windows 2000 computer. Is that going to be okay? I don't think your IT manager is going to trust us kind of connecting that to the internet right away. Okay. Do you trust the data? Nah, we don't. We're just trusting on Fred's intuition. Cool. Um, so what we did is we built out the infrastructure. We managed to pull out that data. We are based just next to Imperial College in London. Turns out the undergrads over there are machines in the best way possible. So what we did with our pipeline, we pulled the data off the production line, fed it straight to these undergrad interns that we had. They built models, simple models, because the simpler the model, the easier it is to trust and the faster it is to trust. Redeployed that model back into production in a matter of minutes, had that validated, and then we could then build the next more complex model to then increase the efficiency of the production line. So very quickly, we're able to increase throughput of the production line by 10%. And we know after a couple more iterations, we can get that up to 50%. And this is through the process of having a subject matter expert over there, subject matter experts over there. They don't have to talk to each other. They don't have to understand what they do, but we have the pipeline that can understand everything that's happening in between. And it's this automation process that can reduce the time to trust or to qualify by orders of magnitude in time and cost. Again, this is based on security and resilience, but really apply this to steel, apply this to your sustainable material, apply this to batteries. Mining, refining, right? There are huge inefficiencies everywhere, and a lot of it is in the hidden cost of handing models and data over and trusting that. So if we solve that problem, we can solve basically all the manufacturing. So thank you.